that equals what?
R squared.
R squared, right? It's just simply the Pythagorean theorem. There's nothing funny going on there. All right? It's the hypotenuse squared. R happens to be what we named the hypotenuse. Now, what is sine theta?
Y over R.
Y over R, right? Opposite over hypotenuse, so Y over R. And cosine is then?
X over R.
X over R. Okay, now, here's the thing. This is what I want to do. So last time we did the unit circle, right? We went through, did the unit circle, and we derived, or introduced the unit circle, and then from that we derived what I'm calling like the fundamental identity of this class. We didn't need to go into the unit circle to do that, and that's what I'm going to show you right now. This is just straight up from the definition of sine and cosine, right? The way we've defined it in class, given a right triangle and one of the angles that's not that one. That's what it means, right? Opposite over hypotenuse, adjacent over hypotenuse. That's just simply the definition. We also know from the very first day that this must be true, since that's a right triangle. And so I didn't need to go into the unit circle to derive that really cool thing. But I did want to bring up the unit circle because we're going to see it so often. I want you to see it more, I want you to see it not just all at once. I want to kind of bring it in a little bit here and there, and then when we actually go to use it the way we're going to use it for the rest of the class, it won't be brand new. So at any rate, what I want to do is somehow use this stuff in here. Is there a way I could get the y all by itself from this equation?
You can put the R up and
bring the R up, and so I have R times sine theta equals Y. Now when you look at this, okay, get in the habit of anytime you see one of these trig functions, just imagine it like a number, right? Kind of like, and that's how we're going to manipulate this stuff if we have it in an equation or something like that. It's just like if you had something like this, y over 3 equals the square root of some stuff. You could think about this entire thing as one number. And if you need to move some stuff around, you could do, say, something like this. But you have it in your head that whatever's inside that square root is all just one number, and it gets multiplied, and all the familiar rules that go along with it are, you could treat it just like a number. Get in the habit of thinking of this thing as one number. It's some number. Yes, it's a function, but the output of it is some number, some ratio. And so it itself, same thing as this, right? Square root, yes, it is a function, but it also, in the end, this represents some number. And so we can treat it like a number. Let's just get used to that. Okay, now what about the cosine? How do I get the x by itself? What's it going to be?
R times cosine theta.
So r times cosine theta equals x. Now let's just substitute these guys into here. We know that this must be true. We know it's true that x squared plus y squared is equal to r squared. And so it must be the case that if I plug this stuff in, right, because we just said this is equal to that, that's equal to that, and so this is just r cosine theta, r times some number which happens to be cosine. This is r times some number which happens to be sine. How can I simplify this? What would that turn into?
You can put the square above the cosine.
And the R.
And the r, right? Because what this means, it's just like if I have 3 times x and then I square it, right? That's 3 times x times 3 times x, and you have the 3 times the 3 times the x, and you get whatever 3 squared is times whatever x squared is. Same thing here. These are just two numbers, and so we have r squared cosine squared theta plus, what's the second one?
R squared sine squared
Sine squared theta. And remember that sine squared and cosine squared, it's just shorthand for putting cosine in parentheses and then squaring what's inside the parentheses. It's just shorthand so we don't have to write parentheses all the time. Now, is there a common factor in every one of these terms here?
R squared.
R squared. Can I get rid of it?
Yeah. Well, yeah.
Can I divide it out? Can I do that though? What if...
Well, what
Yes.
0? But it can't be 0.
It can't be a 0, right? Because if it is 0, well then you don't have a triangle, do you? And so all of this stuff doesn't really make any sense, right? And when I wrote that right there, that would just not make any sense at all, because you can't divide by 0, etc., etc. And so we know r is not 0, so this works. So this cancels, that cancels, that cancels, and I get this is what we had. This is what we went through. We used the unit circle to get that. But I just want to show you, you don't need the unit circle to show that this is true. This is just comes from the definitions and from the Pythagorean theorem. Okay? So it doesn't matter what angle that was. If it was pi over 3 or, I don't know, 2.059 degrees, this is still true no matter what that is. Okay? Everybody with me on that? Everybody buy that? Okay, so I just wanted to go through that real quick. Now, this is what we're getting into today. We're starting with this. This is one of the things you're going to have to memorize for this class. Cosine squared theta plus sine squared theta is equal to 1. Is it true that sine squared theta plus cosine squared theta is equal to 1? Does it work? If I just switch them around? Of course it works, right? Yeah, it's just, you know, I don't want you to, because I think in your homework you might end up with some stuff and you might see it as sine squared theta plus cosine squared theta, and then you're like, uh-oh, what's that? Well, it's the same thing. It's just, oh, we'll get into it. So, okay, now check this out. This class is full of formulas. We could go nuts in this class with just learning formulas. This is one way. If you just memorize this one, you get 3 for 1, basically. If you could memorize it, if you could have this one locked in your head, then there are 2 others from which you could derive this one. And that way you don't have to memorize the other 2. This is what you do. Let me show you. You start there. And now what we're going to do is divide every single one of these guys by, and in practice, it's going to depend on what you're trying to do, but just to derive the other 2, we're going to divide every single one of these guys by, let's start with this one, cosine squared. So I'm going to divide everybody by cosine squared theta. Cosine squared. So cosine squared.
Oh.
What does that equal?
1.
That's 1. What's that equal? There's a trig function that's equal to.
No. There it is. Oh, it's... Yeah.
Because that's the same thing as this, isn't it?
Yeah.
And what's that in terms of trig functions?
It's... Wait. Yeah, tangent.
Tangent. Tangent is equal to sine over cosine. And since that is that, right? Like, this is the same thing as you have a squared over b squared. Is that the same thing as a over b quantity squared? Yes, of course. These are just numbers, right? I could call it sine or I could call it a.
And the other one's secant, right?
Yes, there you go. Okay, so you're getting ahead of me, But yes, right, so that is that. Since that is tangent, this is the same thing as tangent theta squared, which we simplify by calling tan squared theta.
Couldn't we get rid of the square?
How are you going to get rid of the squares?
Divide by 10. 10.
Wasn't that? What, don't they cancel on the top and bottom?
Whoa. Is 3 squared over 2 squared, did those squares cancel?
No. But no.
Nope, that's not
Oh,
over 4.
they're different ones.
Yeah, good question, right? But, and this is the kind of thing, right? When you start, just symbolically, it looks weird, doesn't it? And you're like, well, look, they should cancel. One's on top, one's on bottom. Stop for a second and think, wait a minute, that whole sine theta thing, just like I was saying earlier, that represents some number. And so let's just take some number, call it 3. say some other number, call it 2, and then just test yourself and say, wait a second, let me just see if that's possible. This is true, and so everything we just talked about, that equals tan, and so that works, that's tan squared, etc., etc. Just be careful. And this is one of the reasons why we're going to spend so much time doing the exercises you're doing for homework, is to get you used to doing this type of thing, because this is brand new symbolic stuff. So now you already said, what is this? Secant squared, right? Because this is the same thing as 1 over cosine times 1 over cosine. Notice I didn't write the thetas. Like, I mean, I'm going to do that a lot, like especially when I'm just quickly illustrating something, right? 1 over cosine squared is the same thing as 1 over cosine times 1 over cosine. Yeah, okay. And so together, like that's the same thing as secant times secant, which is the same thing as secant squared. Okay, so there's your second identity. And it came from doing this trick right here, right? We started with one that we knew. We divided everybody by one of these guys. You choose either the cosine squared or the sine squared. And once you divide them, one becomes 1, one becomes tan squared, the other one becomes secant squared. So what do you think we're going to do to get the next one? What are we going to do? We're going to divide everything through by what?
Sine squared.
Sine squared theta. So when I do that, we get sine squared theta, sine squared theta, sine squared theta. Is this legit? Can I just do that? If I have some equation, x plus 1 equals, I don't know, 7, can I just go through and divide everything by something?
If you do it on every side, yeah.
As long as you do it to both sides, right? And I mean, you could do it like this, where you divide that by one number, or you could split it up, you know, either way, it's the same thing. But as long as you're doing everything the same way, yeah. Okay, now what does that give us?
Wait,
Cosine over sine is?
Well, oh, cotangent.
Cotangent.
It's just the reciprocal.
It's the reciprocal of tangent. So we have cotangent squared theta.
Plus
What's
1
plus 1 equals?
tan?
No,
That's
it's
1 over sine.
Secant. Wait. Cosecant.
Cosecant. Cosecant. So that must be cosecant squared. Cosecant squared. And now, maybe it's more, maybe those names make a bit more sense. Because the first time we saw them, the didn't seem to match up with anything, right? We had a sine and a cosine, then we had a tangent and a cotangent, which kind of made sense because one was a reciprocal of the other. But then secant and cosecant weren't reciprocals of each other, so what's going on here? Well, the sine and the cosine, this is why they're called sine and cosine. That's why this one is cotangent and cosecant. They go together. This is secant and tangent. They go together. That makes some sense? Kind of. I mean, I guess there's not really, the pattern isn't quite as nice as I thought it was going to be when I started saying it, but you can kind of see, right? Secant goes with tangent. Cosecant goes with cotangent. Sine and cosine, well, they're together too. So, okay. So these three, and I wrote them like this so that we'd have them for the rest of the class, because they're going to be central to stuff. Okay? So rather than memorizing all three of them, you could memorize this one and then know how to derive these other two. Okay? So, okay, here's one way that this is one of the things you could do with this. And this is in your homework. You're going to have questions like this. So number 36 says write as an integer. And part A gives you something like this. Cosecant squared minus cotangent squared equals 1. Now, I could put anything in the world in there as long as, because right, like theta, you could think about that as x, right? That as long as, we're doing the cosecant of the cotangent. This will be true as long as I have the same thing inside of it. And this, I think, is the first time in your homework you're going to see something that looks like this. One of them says 3 alpha. The other one also says 3 alpha. That's designed to mess you up, and you go, wait, I don't have anything with a 3 in it. Well, as long as they match, right? You could just say, well, let 3 alpha equal theta. If you have to, just go ahead and write that over there and go, let 3 alpha equal theta, and then switch it with a theta, and then you could apply that. But I think you're sophisticated enough now with mathematics that you could say, okay, as long as that's the same thing as that, doesn't matter how funky it looks, it's the same thing. So what is that then? How can we use one of those to figure out what that equals?
It'd be the second one.
Oh, it doesn't, I'm sorry, it wasn't, that wasn't there. That was, I jumped the gun. I jumped the gun. Okay, so yeah, it does equal 1, but let's see, right? You could say, okay, but here's the thing, right? You see this and you think, okay, well then yeah, it must be 1. And you're right in this case, because how do you get there? Well, you take this, subtract him over, and you'll have cosecant squared minus cotangent squared, and indeed that does equal 1. Be careful though, because if it were this, cotan squared stuff minus cosecant squared stuff,
It would be negative.
it would be -1, right? Because in order to get this, you'd have to take this, bring the cosecant over, so you'd have cotangent minus cosecant, then you'd have to bring that 1 over, and it would be a -1. So just be careful with that. Okay? So that's what they mean by write as an integer. Okay, they give you that. And they say write it as an integer. It's pretty simple. Okay. B is just as simple, but there's a trick. They give you this 3 cosecant squared alpha minus 3 cotan squared alpha
Equals 3.
Yeah.
Yeah.
Right? And the thing is, remember, this is just a number. It's some number. It's like a 7, right? And so that's just some number. You could pull the 3 out, just the same way you would with anything else, right? And you have cosecant squared alpha minus cotan squared alpha. And you say, yeah, okay, it's not -1. It's going to have to be the 1, so that's 3 times 1. And so the integer is 3. That's pretty simple. Here's where it's not. Where it's going to get a little funky. So that's obviously, yeah, you're just manipulating these 3 things and da 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 da. Check this out. So, number 40. I think I didn't write this down. I think it says to simplify completely. And we have this. Cotan squared alpha minus 4 over cotan squared alpha minus cotan alpha minus 6. Any ideas on what to do with that?
We can break up the cotangent, the squared into 2 of, well, wait, no.
What if I had written this? If I told you to simplify. Yeah, this works the same way. This works the same way. And this is something that we're going to encounter over and over again in this class, is that this is just, like I said, it's just some number. You could pretend it's x if you like. And if you were to see this, you've been trained to know what to do. In fact, you didn't even think about it. You just said, well, I'd factor it. Like, you didn't have to stop and think about all the possibilities. You've been trained so that when you see this, you know, well, I better factor it. It may not make your life easier, but the odds are it's going to make your life easier if you factor it. We want to try to train ourselves in the same way to say, well, you know what? When you see that, you immediately see a polynomial. You say, yep, that's x squared minus 4. That's x squared minus x minus 6. That's a polynomial. I can factor these guys. The top one factors into what?
Cotangent of alpha
Plus 4 cotangent.
plus 2 times cotangent alpha minus 2.
There you go. Alpha minus minus 2. This is where, again, parentheses are your best friend. And let's just stop for a second and check that, right? First, outer, inner, last. When I get cotan, multiply those together. That's the same thing as cotangent squared. That's the definition of cotangent squared. Okay, great. Outer is negative 2 times the cotangent. Inner is the positive 2 times the cotangent, so they cancel. Now I have plus 2, minus 2, multiply together, give me a minus 4. Yep, that works. So what about the bottom one? What does it factor into?
You have to multiply, because they have to, wait,
But
they have
the
to
6
multiply together to get 6 and add together to get
How would they add to get?
Well, what's the first part here? What's going to go in there?
Cotangent.
Yeah, cotangent.
Cotangent alpha, so let's start there. Cotan alpha.
Could be 3, 2, or 6, and 1.
Okay, well, what is it? Which one do you want to... Look at the numerator. Which one do you want to try? 3 and 2 or 6 and 1?
3
and 2.
Let's try 3 and 2. So here's a 3, here's a 2. And now that won't always work. Sometimes they try to deliberately trip you up, but oftentimes with these contrived examples, there's something that's going to cancel. Now, which one gets the plus and which one gets the minus?
Wait. How do they add together to get cotangent of alpha?
Because first outer, so it would be minus
Outer
3.
and inner,
plus
so we'll
2.
have
I
a
see,
3
okay.
cotans
So it'd be
plus or minus
3 plus
2
2.
cotans. So minus 3
minus
and
3.
plus 2.
Okay.
And let's just double check, right? That's what I want to make sure of. Cotan gives me the cotan squared. Outer gives me minus 3 cotan. Inner gives me plus 2 cotans, or apples. 3 apples, minus 3 apples, plus 2 apples gives me minus 1 apple. So minus 1 cotan, minus cotan. There you go. And then the last gives me plus 2 minus 3, which is minus 6. So does anything cancel?
The alpha 2
Plus.
thing.
There we go. Okay, and so now we got this. Now here's the thing. This is an even number, so I don't know what the book is looking for in this case. The ones that I've given you are odds. So when you get to this point, you look in the back of the book and say, am I done? And it might not be done, right? They might want you to continue on here. In which case, well, those things obviously as polynomials, you would have had x minus 2, x minus 3. That's done as far as that's concerned. But in this case now, cotan is what over what?
It's
Hypotenuse over.
No. Oh yeah. It's hypotenuse over opposite. Yeah.
No,
Oh no, it's
no,
cotangent.
no.
So it's adjacent over opposite.
I don't care about adjacents and opposites because we don't have an actual triangle, do we?
Oh.
So what is it in terms of the trig functions?
Oh.
1.
In other words, okay, so this is what I'm getting at. Once you get down to this point, technically we're done, but maybe there's something in terms of sines and cosines. And for everything we're going to do today, that's going to be something we're going to stop and check. Because sometimes, with the first ones that we did, we didn't need to turn everything into sines and cosines, right? Everything was it just worked out. In this case, so what is this?
1 over tan.
Okay, but in terms of sines and cosines, if that's 1 over... Tangent is what over what in terms of sines and cosines?
Sine over cosine.
So cotangent is
1.
Cosine over sine.
cosine over sine. So cosine alpha over sine alpha. Same thing down here. Cosine alpha over sine alpha. Now, I don't know, and so this is what I'm getting at. If there was an answer in the back of the book, maybe that was the answer and I could stop. If not, maybe it's in terms of sines and cosines, and maybe it looks like this. But now I have denominators in denominators. How do I kill those denominators right there?
Multiply by sine.
So let's multiply both the top and the bottom by sine and see what happens. So that's going to kill the first sign, leaving me just a cosine alpha. Distributes in, and now I have minus 2 sine alpha. In the bottom, that guy jumps in, kills that sine alpha, leaves me with just a cosine alpha minus 3 sine alpha. And maybe that's what's in the back of the book. I can't think of a way to break that down anymore. But this is the kind of thing you're going to do. With these right here, the 40 through, or 39 through whatever, the ones that do this, you know, that say to simplify, just keep, there in the back of the book, there's answers. Just keep going until you get what the book has. The book might have stopped here, it might have stopped here, it might have stopped here at some point, you know, whatever. Questions on this? No, let's do another one that's a little funky. This is 42, and it's also says simplify. Two says simplify, or it might say right in lowest terms. I'm not sure, but at any rate, this says cosecant theta plus 1 over 1 over sine squared theta plus cosecant theta. Now, right away. So we have a few options. Are cosecant and sine related?
Yeah, they're reciprocals.
So
it would be nice to turn one into the, maybe, I don't know, maybe it'll help to turn one into the
1
other.
over sine is the same as cosine.
What?
No, cosine is the same as 1 over sine.
1 over sine is equal to what?
Cosecant.
Cosecant, right? And so then 1 over sine squared would be cosecant squared. So I'm thinking, and there's no wrong way to do this, really. There's more difficult ways, but I'm seeing three things. One of these kids is not like the other. And so let's take care of that one guy instead of taking care of two guys. I don't know, maybe it'll help, maybe not. It might be going down the wrong road, but it just seems to me that we do the smallest amount of work here. So this stays cosecant theta. This then becomes, well, hold on, let me just, yeah, there you go, right? So cosecant squared.
And you can factor out cosecant.
There you go, right? Because this is the same thing as x plus 1 over x squared plus x.
Oh.
And if you factored one of them out, hey, look at what's about to happen. And so, give me a second. We have cosecant theta plus 1. I'm going to factor one of those cosecants out. And I'm going to have cosecant theta times what's left over. I pulled one out of there, leaving me one of them.
Cosecant alpha, or theta plus 1.
This is theta, yep. And then plus 1. Does something cancel?
They're cosecant theta plus 1.
There we go. And so we have 1 over cosecant theta. Is there a simpler way of writing that?
Sine theta.
Sine theta, right? Because they're reciprocals of each other. And so this is sine theta. Then you check the back of your book. And at any point along the way, you could have checked the back of your book right here. And the back of your book says, no, it's sine. And you go, oh, right, yeah, okay, yeah, there. But do check what the back of the book says for these in particular. Okay? All right, so that's one thing. That's another thing you're going to encounter. Yes, so I said check the back of the book and keep going if necessary. All right? That's the idea with those. Now another thing. So let's go back to these guys right here. Watch what we can do. I might want to change that, because what are we going to do here? Yeah. I don't want to change that one. Do I want to change that one? Sorry. Yeah, why not? Okay. So, starting here, we have cosine squared theta plus sine squared theta equals what? 1. Better, okay. Now, watch this. I'm going to isolate one of these guys. I'm going to keep him here, making this like this. Now, I can take a square root of both sides. Right? Because that's the same thing as x squared equals some junk. And if I wanted to get down to the just bare minimum x, I could just take the square root. When I do that, what happens when I take a square root?
Plus or minus.
I get a plus and minus. So I'm going to put my plus minus right there. And I have then cosine theta equals plus or minus the square root of 1 minus sine squared theta. Now, right now, we have not officially extended. I've showed you what we're going to do on the unit circle to get positive and negative values of sine, cosine, and all of our friends. As of right now, we haven't done that yet. Okay, officially, we haven't done that. And so, in this section, all the angles that you are going to be dealing with are going to be between 0 and 90. Or in radians, 0 and pi over 2. So everything's in that first quadrant, right? That's how we're going to think about this. And if you're in the first quadrant, so in other words, theta is some angle between 0 and 3. In other words, all that's saying, it's a fancy way of saying you have a right triangle, right? You have, because that's your right triangle, that's an acute angle. It's less than 90 or less than pi over 2. And so, everything we're talking about here, all of the values are positive. All right, it doesn't matter if this is like a 7 and 13 or whatever. Sine, this is also a positive value. Sine is going to be some positive number over some positive number, so sine's positive. Cosine is going to be a positive number over a positive number, so it's positive. Therefore, its reciprocals are positive. And then since tangent is just sine over cosine, that's a positive over a positive, it's a positive, and its reciprocal must be a positive. So in this context, when you have an acute angle, I think that's how it says it. It says blah, 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 for acute angle theta. This is what they mean. All of your values should be positive. So we can conclude what about this plus minus thing? Which one are we going to take? The plus.
Also, wouldn't it... So, wait. 1 has to be bigger than sine squared theta?
It will always be. It will always be.
Oh, well, yeah.
It will
Otherwise
always
it's
match. Because if you think about take your favorite triangle. Okay. Wow.
It's like a 1,
Okay,
9,
there's
9.
your, yeah, right? Like, this is some number, call it 1. This is bigger than 1. Right, whatever that is. It is bigger than 1. You take 1, divide by something bigger than 1. Okay. Well, what about the other extreme?
Yeah.
The other extreme, you have a really big one like that, right? And, well, nonetheless, the hypotenuse is still bigger than that side, right? The hypotenuse is always bigger. And so when you take both, and this is true for both sine and cosine, they're going to be,
When the hypotenuse
there will be
is on-
less than 1.
But tangent could be...
Tangent. Oh boy. Wait for tangent, cosecant, cotangent, and secant. That's going to be, that's a
Anything
different
without hypotenuse on the
monster
bottom.
altogether. But as far as this is concerned, so it is true, and we will talk when we do unit circle, we are going to go in depth about the ranges of all of these guys, like how big can their outputs be, and etc. But yep, you nailed it, right? At most, that can't get any bigger than 1. And if it's not exact, if this is not 0, and it's not pi over 2, which I'm saying acute has to be between here, then it will be less than 1 and bigger than 0. And so, but we'll get into all that. This is just, we're just playing with an equation right now. And we're noticing that, well, since cosine has to be positive whenever you have an acute angle, well, that guy's got to be the positive one. That's all we're saying. Now, check this out. I just wrote cosine in terms of sine. Right?
Yeah.
That's kind of cool. Huh. Let's see. So, another thing that they're going to have you do.
I mean, no, that's fine.
Okay. So, everybody got this?
Yeah.
Okay. I might as well go ahead and put it. Whenever we have an acute angle, it will be true that cosine theta will be the positive square root of 1 minus sine squared theta. And sine theta will be what?
square root of 1 minus cosine.
There you go.
Squared.
There you go, right? And, but it's the same thing. You just leave sine on that side, bring cosine over, take a square root, and since we're talking about positive stuff, the square root is going to be the positive one. Okay, so that's just up there. And again, this is not a new thing you have to memorize. How cool is that? All you need is this one. From here now, you memorize this one, you got 1, 2, 3, 4 for free. How cool is that? So, for these, you have a bunch that say, write the first in terms of the second. Let's be consistent here. And they're going to give you two things. So for instance, number 44. It says, write the first in terms of the second. The first they give you is tan theta. And you want to write it in terms of cosine theta. So we want to write this. So notice what I just did. I wrote sine in terms of cosine. I wrote cosine in terms of sine. Now we want to take tangent and write it in terms of cosine. So I should have...
Write tangent in terms of sine and cosine.
There you go. There you go.
Sine into just...
There you go. There you go. So the idea here is you should have tan equals junk, 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 and then finally equals, and all you see is cosines. Maybe there's square roots, maybe there's some stuff squared or whatever, but everything here in the end should only have cosine in it. That's what it means in terms of the other. And so you said I could write tangent in terms of what?
Sine and cosine.
Sine and cosine, so which one goes on top?
Sine.
Sine goes on top. Sine theta over cosine theta. And now what do I do?
The square root of 1 minus cosine squared theta over cosine.
There you go. Square root of 1 minus cos squared theta over cos theta. Is that entirely in terms of cosine theta?
Yeah.
Yeah. There's no other trig functions in there. There's not a hidden secant or something. Well, actually there is, because this over that. But anyway, but I've written it out explicitly. Like, this is actually bears saying. If you had something like this, you're doing your work and blah, 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 and then you have this, you could say, well, wait a second, secant is 1 over cosine.
Oh, yeah.
And so then this, bring that into the denominator, and you have your cosine, and so just rewrite it so that all you have is cosines, etc. Okay? We're being explicit. They are exactly equal. It just says this is exactly equal to that. It means the exact same thing, as long as you have acute angles. So you know that you took the right one, the correct one. You took the correct root, either positive or negative. And now all we see is cosines, etc., etc. Okay, so that one's pretty straightforward. There's some other ones that aren't too bad. But then you get this. Okay, so get ready for this one. And I'm just going to talk you through what I did when I was working on this last night. All right. Writing the first in terms of the second, we're writing cosine now in terms of cotangent. Okay? Now watch this.
Opposite of, wait, no.
You can write cosine as sine. Wait.
So I want to walk you through my reasoning here. I thought, well, normally I would want to write cosine here, do a bunch of work, and then have something involving just nothing but cotans. But what I know, and so maybe I'll do some scratch work first. And this is my scratch work. I was like, I do know that cotan theta is equal to what over what in terms of sines and cosines?
What? Wait, sine. Oh, it's sine over. No. Cosine over sine.
Cosine over sine. And so I thought, okay, well here's this.
Oh.
And then I thought, okay, well then what I could do then is if I want to get the cosine's the thing I want over here, and so
we're doing it backwards.
I could say, yeah, and that's kind of what I started saying. I could, I'll keep everything on the correct side. So then I said, well, I'll just bring him upstairs. So I have cotan
sine equals cosine, okay? Okay, so that's, I want the cosine in terms of cosine, so I get one cotan. Now I need to get sine in terms of cotan. It sounds very much like what I was, the original problem. Wait a second. And this is going to happen so often as you're doing this kind of thing. You're going to go, wait a minute. Don't get pigeonholed. Don't assume that just because the one that you did before was amenable to this kind of reasoning, that the next one's going to be, that's the way you should think about the next one. And so I said, no, wait a second. And I thought, cotangent. You know, I have something up here that has a cotangent in it.
Cotangent plus 1.
Yeah.
But
And
then-
so,
no,
wait a minute, did I write this right? This is cosine.
So you can put the 1 over and then substitute in the...
Yeah, so I need to write the cotangent. So let's think about it this way. So this is what I'm getting at. Like, maybe we want to branch out and use some other things we know besides just whatever. So, but another thing I know, and this is what's kind of nice. That guy's cosine, isn't it? Like, he's 1 over cosine. Secant is 1 over cosine. So maybe I want to start there. Because watch what happens when I do that. 1 plus tan squared theta is equal to secant squared theta. But secant squared theta is equal to what?
1 over
1
cosine
over-
squared.
Well, there we go. Right, so watch this now. I'm going to take this guy upstairs, bring him up here, cosine squared theta, and I'm going to bring that guy downstairs. Now, it's not tangent that I want to write it in terms of, it's cotangent. So how do I turn a tangent into a cotangent?
1 over.
1 over it.
So tangent. So it's just
1 plus 1 plus
1
1 over cotangent squared theta. And now, are we almost there?
So it's just cotangent. Wait.
No, because think about it, right? If you have 1 plus x squared, and then you change that to, say, 1 plus 1 over y squared. I mean, you could, if you want, you could then multiply the top and the bottom by cotan squared.
Yeah.
You could, and maybe that's how your book is going to want you to do it. But as of right now, that's fine with me right there. Because what are we supposed to do? We're supposed to, on one side, have this, and then a bunch of stuff, and then nothing but cotangents over here. Do we have nothing but cotangents over here?
Yeah.
The only thing left to do is get rid of that square. How do I get rid of a squared?
Square root.
Take a square root. And am I going to take the positive or the negative of this? The positive, because we're assuming it says in the beginning, it'll say, write the first term second, assuming that theta is acute. And so, we got this guy right here. There you go. Yikes. So, you're going to need to be a little creative, right? And you could have gone back and forth, like I said at the beginning, right? We have cotangent. We knew that cotangent was cosine over sine. And we wanted to get the cosine, so I could have said, okay, cotan times sine is cosine. And then, okay, almost there, maybe somehow I could get cotangent in terms of sine, and maybe I could, whatever, right? Maybe you end up, that's a fruitful way of going, but if you start to get stuck, maybe try something else. And these are the things that you might want to try, right? Get used to dealing with these guys. Now, let's say you look in the back of your book, and the back of your book says that it should be this. Or maybe it probably wouldn't even be written like this. Cotan squared theta plus 1.
Yeah.
It probably would be written like this. Cotan theta over the square root of cotan squared theta plus 1.
Everybody get that, right? What did I do here? I multiplied the top and the bottom by cotan squared,
Yeah.
right? In here, if I multiply the top by cotan squared, I get that. If I multiply the bottom by cotan squared, that guy cancels, leaving me a 1. Cotan squared comes over, hits that guy, we get cotan squared. Top and the bottom, oh, that's just a pure squared, so I could pull him out. Maybe that's what your book says right there, right? So keep going until you get what the book says, right? And make sure you know how to do that too. Like, don't just see your answer and then see that and go, yeah, it's probably the same. Sure, then just write equals. Yeah, we're good. Like, I'll catch that and I won't believe you. Like, so that's what I'm getting at, right? Any questions with this? This one's brutal. This is a brutal one. These are just...
Wait, the next one? Wait, or this one?
This one, I think this one's brutal. I mean, especially because the first one, you're like, oh, that's just that over that. And then you just substitute that. Easy. And this is like you try to go using the same kind of reasoning as before, but you needed to use something completely different. And then there's all kinds of flipping around and stuff. But all of these exercises are to get you used to this, because doing this actually, it turns very, very, very hard problems into simple problems. That's what all of this is about. We'll go more into that, and I'll say more about that a ton later. But right now, that's what we're doing. Now, this is the bread and butter of this is what we really care about. These types of problems. Can I get rid of all this?
Yes.
Okay, I'm gonna leave. Might as well leave that up. Okay, from now on in this class, we're going to call the types of problems we're about to do, we're going to call them identities. And you are to verify. This is what it's going to say. Verify by transforming the left-hand side into the right-hand side. I will use these abbreviations often. LHS for left-hand side, means of an equation, left-hand side, into the right-hand side. Okay? And so it starts off by giving you an identity. Here's number 54.
So we can't do the right-hand side into the left-hand side?
You know, and that's what we're going to talk about. That's what we're going to talk about in just a minute. So this one is cotan theta secant theta equals cosecant theta. This one's pretty simple. So what we want to do, okay? This one is simple, and oftentimes they give it to you so that the more complicated one is on the left-hand side, and 9 times out of 10, that's where you want to start. Anytime you're given an identity to verify, find the more complicated side, this one's obviously more complicated, and turn it into the less complicated side. It's usually how you want to do it. It's usually how they present it. They put the more complicated stuff on the left-hand side. It won't always be that way. Sometimes you'll run into some weird ones, but that's usually what you want to do. So what I'm going to require, maybe it takes you, and you'll see the last example that we're going to do, it's going to do what I'm about to say, where you're going to have to do a bunch of work on one side, a bunch of work on the other side, and then somehow connect them. But in the end, after you've done all your scratch work, I want to see this like a proof. You're trying to prove that this equals that. And so just like we talked about last year, anytime you're trying to prove that something is equal to something, you don't like do some stuff over here, do some stuff over here, then say, oh, they're equal and therefore everything's equal. It's just bad form, right? We want to get into, that maybe what you have to do in order to get it done, but in the end, I want to see this. You start on one side, step, 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 up, other side pops out. So for this one in particular, we're going to start on the left-hand side with
cotan theta, secant theta. And oftentimes, not always, especially if there's something like this that you want to use. If you start seeing cotans squared and secants squared and stuff like that, you might want to use one of these guys. But sometimes when you see this, the easiest thing to do is to turn everything into sines and cosines. So let's rewrite this in terms of sines and cosines. What is cotan?
It's cosine over sine.
Cosine theta over sine theta. And then what is secant?
1 over cosine.
1 over cosine. Does anything cancel out?
The cosine.
The cosines cancel, leaving me what?
1 over cosine. 1 over sine.
1 over sine, which is what?
Cosine.
Oh.
Cosine.
Okay, so now look, this is how I'm reporting this. If I did a bunch of other work somewhere else, I would finally want to come back and this is my final answer right here. Left-hand side, some stuff, and this doesn't have to be on one line. In fact, as I do these, I usually go down, right? And this one is amenable to doing it in one line. Oftentimes you'll have multiple lines, that's cool, but here's the thing, this equals something equals that. Cool?
Yeah.
Questions? Okay. That was simple. This
Now
one's not so simple. Actually, this one's not bad. This one's not bad. So, that's 54. I think this, yeah, 54. This is 56. Okay, so this one, they both look a little complicated. The one on the left does look a bit more complicated, and again, it's usually how they give it to you when they say left hand into right hand. Left hand is usually more complicated. That's the side I'm going to start with. First thing I'm going to think about is, well, over here we have cosines and sines. Over here we have just cosines. So is there a way I could turn this into something that's just cosines? There's a couple different ways. So I'm going to start by writing this out because this is what I expect. Okay, I expect that you start there. Now, equals. Here's the thing. There's a couple different ways we could do this. We could say, well, sine is that right there. Therefore, sine squared is whatever that is squared. Or there's that right there. Don't let this 2 theta mess you up, right? It's 2 theta in every single one of those. Later on in this year, we will have, that will matter, and we'll want to say, oh, wait, sine 2 theta is equal to some blah, 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 blah. But right now, what I do, the thing I'm looking for is every one of these 2 theta? Yeah, okay, all right, there's nothing funky going on here. So, this right there is that right there. And so this right there is the same thing as that minus that.
Yeah.
Right? So I could say, okay, here, I'm just going to minus stuff. That stuff is 1 minus sine squared. Ah, geez. Cosine squared, sorry. Everybody with me?
Yeah.
Check me. Is that right?
Yeah.
That thing is equal to 1 minus cosine squared. Yes, okay. And so, this is the same thing as cosine squared 2 theta. The minus comes over. The minus comes over.
Oh.
Uh-huh.
That's it.
Yeah. And so you have an apple minus 1 plus another apple. You have 2 apples. Just put your apples together. You have 2 apples, 2 cosine squared theta, 2 theta, minus 1. Is that where we wanted to go?
Yeah.
Done. Again, right? Sometimes
You want to use these guys. Sometimes you want to use these guys. Sometimes it just kind of pops out, right? But you want to be fluid, right? You want to be able to jump from one type to the other. And oftentimes, if you're just stuck somewhere, maybe try one of those that you haven't been using before. Oftentimes, if you're stuck, turn everything into just sines and cosines. That can make your life much easier. Okay, here's another one. You know, a lot of these, like in your homework, it's going to be like this one, the one that I'm about to write up, where it's literally just like, just work out what's on the left-hand side, and it works out. So this one is 62. And it says verify at the right-hand side. Is that minus? Yes, minus. Wow. Verify that. And what's nice is that the left-hand side is very much more complicated than the right-hand side. And so, oftentimes when I see something like this, I'm like, well, let's just start multiplying it out and see what happens. And so that's what I'm going to do. Okay? And because I want to model for you what I expect, I do expect you to write the whole thing out as though you're doing a proof. You're going to start by writing out the left-hand side. Now, what do we got to do to multiply this guy? What's it going to work out to? There's an acronym that so yeah.
One
First 1, and then what?
plus tan squared of theta.
There we go. So first outer, then
Minus sine squared.
minus sine squared theta. Finally,
Plus sine.
plus.
Oh, minus sine squared theta times tan squared theta.
Now right here, I look at this and I go, that doesn't help. Like, that's not 1. That's certainly not 1. So what I suggest at this point, what I would do, I would say, well, maybe it'll help me by turning everything into sines and cosines. And so that's going to be my next step. I'm going to go ahead and write everything in terms of just sines and cosines. So 1 is still 1. What's tan squared?
Sine squared over cosine squared.
Sine squared over cosine squared. Now, minus. Sine squared is just, well, sine squared. Now, minus sine squared is just sine squared. Times what?
Sine squared over cosine squared. Oh.
No.
So you have minus
You
2
can
sine
combine the
squared.
sine squared.
So you have 1 plus.
Wait.
Oh no, that's times, right?
Well, we had the same denominator on the cosine theta,
Oh, so you can put those
so we can
together.
put those together.
We could.
And that gives us 3 sine squared over cosine.
No, that's also times.
Wait.
I'm gonna do it this way. So sine.
We could, and then let's see what would happen. It would be all over cosine squared. I'm not going to bother with the thetas, but we would have sine squared minus sine to the 4th.
Yeah. Oh, and that is a difference of squares.
It's a difference of squares. You could also factor out a sine squared, leaving you 1 minus. Hey, buddy, leaving you 1 minus sine squared. What's 1 minus sine squared?
Cosine squared.
Cosine squared. No, buddy, no. I gotta teach right now.
So they cancel.
So yeah, so then you would get there, right? This is the way I did it. I just want to show you. This is the way that I went about doing it. But just to show you, like that's another that there's more than one way to get here. But what I did is I said, well, hold up, wait a second. Sine squared is the same thing as 1 minus cosine squared. So I just went ahead and did it right here. 1 plus, and just for interest of time, I'm not going to write the thetas. You had better write your thetas. So, for right now, eventually we'll get to a point where you won't, but right now, I do want you to do that. So, sine squared is the same as 1 minus cosine squared. Now, let's go ahead and put that guy in. Sine squared over cosine squared minus sine squared. This guy jumps over. And in the 1, we have sine squared over cosine squared. The cosines kill each other.
Yeah.
And so we're just left with sine squared. Now let's think about the minus comes in, makes that a minus. Minus comes in, makes that a plus. This guy cancels that guy. That guy cancels that guy. And you are left with a 1, which is what we wanted to show.
I think I want to try.
Now, the way that you were saying is like, hey, they have a common denominator. Put them together. And we would have ended up at the same place, actually, which is pretty cool if you notice the trick, right? And you go, wait a minute, what's 1 minus cosine squared? Oh, yeah, right. And so keep this in the back of your mind. Keep these in the back of your mind the whole time, especially when you have squareds in there. Maybe you want to do that, maybe not, right? Or maybe it'll help, maybe it won't. But that's, and there's more than one way to get there, okay? So I want to do one more. I know we're running out of, buddy. Yeah, we'll do one more because I want you to see this. So here's another, here's the last one.
I got this on the church.
Yes, it did. Now you're getting mud in here. Come on, buddy.
Money,
No, no, careful. Here, come on.
money puddle.
Cotan theta plus tan theta
Here. We're gonna do
is
that. Get out here.
equal to cosecant theta secant theta.
Rush.
Now, when I'm doing this, the first thing that I did, I said, you know what, I'm just going to go ahead and turn everybody in here into just sines and cosines. And so, cotan. And so, this is, so I want to show you, this is what I would do. Here's my scratch work. And then I'm going to have my actual write-up. The thing that I turn in. If you want to put your scratch work on your homework, that's cool too. But your write-up had better start with this, take definite steps, and end up with that, as we're going to do. But here's my scratch work. I'm just going to start by rewriting this entire thing in terms of just sines and cosines. So cotan is cosine over sine plus tan is sine over cosine. That equals cosecant is 1 over sine times secant is 1 over cosine. Now here's something I notice. You'd say, well, wait a minute. That's, well, actually, that's the same thing as just 1 over sine times cosine. And that's all, if I were to get a common denominator, that's what that common denominator happens to be. If I wanted a common denominator, I would have to say, okay, we have this right here plus this right here. In order to get a common denominator, I'd have to do cosine here. So I'm going to go cosine, cosine. Down here, I'm going to go sine. Up here, I'm going to go sine. And now I notice, oh, I have my common denominator. So I have my sine times cosine. Up here, I have a cosine squared. Up here, I have a sine squared. Oh, what's cosine squared plus sine squared?
1.
Is that where I'm trying to go?
Wait. No.
Yeah, yeah, right? Because 1 over the sine times cosine. That is what I want. So this is what that's what my work looks like, right? And like, so help me, if this is what you turn in, you'll get 0 credit for that, right? Like, you may have to do this kind of work to see how you're going to go about doing the write-up. But this is what, now that we've done that work, I can see the route I'm going to take. I'm going to start here with cotan theta plus tan theta. And I'm going to say that's the same thing as cosine theta over sine theta plus sine theta over cosine theta. And I could do this in the same line, I guess, that's fine. Now I'm going to get the common denominator by going times cosine theta times cosine theta. Down here I need a sine, so I'm going to go times sine theta. Up here I'm going to go sine theta. That gives me my common denominator of, we'll do it as sine cosine. So there's my sine cosine. On the top we have a cosine squared. On the top we have a sine squared. What's cosine squared plus sine squared?
1.
I could say that's the same thing as 1 over sine theta times 1 over cosine theta. Everybody buy that?
Yeah.
Right? Okay. And you see, I wouldn't have known, like, that, I wouldn't have felt that this route was fruitful without having done this too, right? And so this is what I'm saying, like, sometimes to actually figure out how you're going to do it, you might need to work on both sides. But this is a really terrible proof here. I wouldn't call that a proof. This is just scratch work. How you're working out how you're going to get there. But now that I've seen how they're related, now I can go back and put it all together so that I start with the left-hand side, do some magic, and end up with that 1 over sine is cosecant theta times 1 over cosine is secant theta. And that is where we wanted to end up. And so this is my final write-up. That's my final answer right there.
Do you do the box with the...
Peter, no. Leave it alone. What now?
You do the box with the...
You could, if you want. That's cool, right? That you say as QED, right? As was to be demonstrated. Or you could write the Q, E, D. And there you go. So, like I said, do not wait to start these. These are wicked hard. And this type of stuff, being able to transform something that looks like this into something like this, later on in your mathematical life will be the difference between a problem that's literally unsolvable, something you literally cannot do, into something that may turn out to be very trivial. Like, oh yeah, I know what the answer is now. It's very useful. So we're going to, as much as possible, we will exercise this faculty. These are good exercises, and you're going to see these all the time. These are verified. And I want you to treat them as proofs.